shouldn't be possible. Sometimes a number appears, not in a dramatic way, not glowing on a screen, not written in bold. It just shows up. In dates, in measurements, in collections of data that were never meant to be connected. At first, it feels harmless. Coincidence. The kind of thing the human brain is known for noticing. We are very good at finding patterns, sometimes even when none exist. But this time, the number doesn't stop appearing. It repeats. Across datasets, across locations, across time periods that should have nothing in common. When researchers notice this, they don't jump to conclusions. They slow down. They document. They ask a careful question. Is this expected? Statistics is built on expectation, probability, distribution, how often something should happen, if randomness is behaving properly. So the number is tested, compared against models, run through simulations, checked again. At first, the results seem reassuring. The number appears slightly more often than predicted. That can happen. Randomness allows for clusters. But then it happens again and again. In data sets collected by different people, using different methods, in different places, the probability margins shrink, the confidence intervals tighten, and the number remains. At this point, researchers become cautious, because there are known traps: selection bias, reporting bias, human choice influencing outcomes without anyone noticing. So controls are added. Human input is removed. Data is randomized. Blind analysis is introduced. The pattern weakens, which is expected. Bias usually leaves a fingerprint. But the number doesn't vanish. It still appears. Less often, but more often than models predict. This is where explanations diverge. Some point to hidden constraints, limits built into how data is gathered, rounded values, measurement thresholds, structural quirks that repeat quietly across systems. Others look at randomness itself, not as chaos, but as something shaped by physical reality. True randomness is rare. Most systems only approximate it. And then there are the remaining cases. The ones that persist, even after adjustments, even after corrections, even after known explanations are accounted for. They don't prove anything. They don't confirm a hidden rule. They don't point to intention. They simply remain. A number appearing more often than expected. Statistics doesn't call this impossible. It calls it unresolved. And for now, the data waits. Would you have believed this